Today is a big one. Kerb Outstands and raised crossing, so much so I couldn't fit it on the PowerPoint slide. But for those of you that saw the newsletter, you will have seen, and if I can just make sure my mouse is on the PowerPoint, that today we're going to be looking at generating a design for this existing intersection. You can actually see this existing intersection has had pretty much what we're going to be looking at today already constructed. However, it's a great way of sort of giving some context to what we're going to be putting in today, which is the following. So the Kerb Return on the right-hand side that you can see here has already been essentially designed, and we have put that into the model. So we're not going to be duplicating and spending more time doing the same thing twice. Our focus will be on designing the Kerb Return on the left side here, tying into the existing surface, and in actual fact I might as well pull up this sort of rough design outline. It's almost really an agenda of what we're going to be doing today. So designing two new outstands, one of them has just been done. In theory, we're going to be matching into the existing road, existing surfaces. We're going to be adding a new footpath, which will be constrained by an existing boundary. Following that, we're then going to be creating a raised crossing between the two new outstands. And in a nutshell, we're going to be creating three separate models. Okay, now, once we've done that, we're then going to be producing long sections and cross sections. Really, this is the output part of this particular webinar. Having chatted with Todd, and the reason why Todd is actually hosting this today is because Todd's background is essentially within council and this type of design work. Todd, you've done quite a bit with particularly with civil site design. This particular type of project that we're looking at is something you've actually got experience with, isn't that right?
Yes, that's correct. I've done this on designs for these on a number of intersections or variants of this type of design. It presents its own design challenges, but there are some really nice tools in civil site design that help you through.
Yeah,
help you to get that stuff done.
Well, and Todd will be jumping in all the way through this webinar, offering little tips and tricks and bits of advice, certainly having been at the coalface. Now, just a couple of things really in relation to how we're going to approach this design. I know for many people that when they look at this initially on plan, they go, okay, so I need to use the intersection tool with civil site design. I need two road strings, and I need to create these as Kerb returns using the network string tools. That is not going to be in play here whatsoever. If you've watched sort of my most recent webinars, I've really strayed away from using the network string tools completely. And that's not to say they don't have their place, but in a scenario such as this, it really is using a sledgehammer to crack a nut when it comes to the design process. So we're going to be designing independent strings, creating little models of each part, and then combining them together. And for the production, that shouldn't be a problem. So for this particular Kerb Return, the one we're looking at on the right-hand side here, we've actually got an existing crown, which is just labeled down here. We've got an offset crown. Now, this crown, as you can see, is just positioned here. So I've called it offset crown. So if you've got another term for it, I apologize. The slope between that particular location there and where our saw cut will be matched onto the existing surface, that slope needs to be projected through to set the elevation of basically the center line of the control of our Kerb Return. Now, your control for your Kerb Return, if you're doing this, may actually be the invert. Okay, and I will discuss how we can actually manage the fact that the control or the center line of your design might be the invert instead of what I'm using here, which is the lip or the edge of bitumen. So we'll cover that. So there's two potential options. The other piece really is looking at the footpath, and the footpath has got a constraint where we need to match onto the existing boundary, and then we need to model the whole lot together. Following that, we're then going to look at how we can create the raised crossing. And this presents a number of different challenges because you're going kind of against the grain of your model. You're kind of cutting away from it as opposed to with it. So we'll have a look at how we can manage that and how that can be created. Just before we move on, I'd actually like to just give a little bit of a plug for City of Parramatta, because this is the type of thing they've been doing. And we have a particular user over there called Lilac, who's one of the designers. And this is an example of the type of work that they have been doing with civil site design. So you can see there's a slight difference where we've got the channel cutting behind the island here. But this is the type of thing that they have been achieving with civil site design. And they've been and as you can see, Lilac's absolutely nailed the model viewer objects and and materials and renders and whatnot to basically produce a very, very well rendered model. So let's have a look at the design. So let's just jump in. First of all, Kerb Return 2. I've already created Kerb Return 2, so let's have a quick unpack. And it is going to be quick because all of the principles I've applied to Kerb Return 2 are going to be applied to Kerb Return 1. First of all, if we open up a cross-section of Kerb Return 2, sorry, I'm calling it Kerb Return 2. It's Kerb Return B. So if I keep calling it 2 in the webinar, I apologize. So the idea with this is that the saw cut is matching onto the existing surface, and this isn't necessarily going to be perfect, but it's matching onto the existing surface. And we have an alignment, a Civil 3D alignment. I'm running this on Civil 3D today, but if you're running the Civil Site Design Plus BricsCAD or AutoCAD versions, then feel free to create those alignments instead. I've also got a match code. Now, this match code essentially is that's an existing curb here, an existing footpath. All I'm doing is taking a code, which is this match code here. In fact, if we open the section data, you can see it. And I'm simply taking it from the back of my curb and draping it onto the existing surface, which you can see here, but also using this wonderful little alignment, which I've already created, sort of to fill this in. So Kerb Return 2 is relatively straightforward. Its vertical design is using a principle that I've really covered in a couple of my last webinars, which is string techniques, or independent string design, and curb row widening. And we're going to be unpacking how to use reference point to set the elevations as we need. You'll notice that we have no template. So I'm not using templates to help me set the elevations of this center line. So I'm going to show you how you can do all of that. Kerb Return 2 or Kerb Return B is pretty much good to go. So what I need to do is now start looking at Kerb Return 1 or Kerb Return A. I'm going to make sure I call it A because that's how it's referred to on the 3D alignment. Just before we do that, let's have a quick look at the template. This is the one that we're using for the opposite side. So let's just flick down, go to the right side. So with the alignment going south-north, my curb will be on the right-hand side. I've also got a saw cut, which is 600 mil off on the left-hand side. And really this slope in here is going to vary, whilst the rest of it's going to remain as is. I've also got a template for where we actually get to the crossing. And you can see there that the key difference is that I'm gone from 150 mil curb face to a 75 mil curb face. So where we basically want to present the crossing at this point here and this point here at the top, we really want a smaller curb face. So I want to be transitioning to that 75 mil curb face, maintain that all the way through, and then transition back to a 150. So I've got my templates all ready to go. Really, it's just a case of starting to look at the creation side of things. Now, as I said, many people look at this point and go, well, I'm going to create a T intersection with two roads and then try and have the software use the Kerb Return tool to do all of this. And whilst, yes, you could do that, there's a lot of extra workings that you have to sort of manage in the background. This can just be a single string with a template. And really, the string to use is a profile string. I'm going to click on profile string. Going to click near the alignment that I'm going to be using here, Kerb Return A, as you can see there. I'm going to pick the template we just saw, which is right side with saw cut. The surface I'm referencing in the background is the NS. And how often do I want to reference this surface? Now, Todd and I were having a discussion about this. When you're designing a string such as this, you probably want some quite tight sampling. The problem with that sampling is that it automatically becomes part of your long section plotting. Regardless of IPs, you have to go through and then uncheck all the ones that you don't want. So there's a little bit of a trick here. If I put in for tangents and maybe for arcs, and we'll just put spirals down as well. That's fine, okay? But do I want to have an offset on my long section or a vertical line on my long section every meter that I've then got to go and clear out? No, I don't. The trick is to use user sampling. So what I'm going to do is say from 0 to 100 or 1,000, use a spacing of 0.5 meter. Okay, that. But for my main string, I want a sampling of 5, of 5, and 5. The user sampling, by default, doesn't get presented on your long section. You can go in and choose them later on if you want, but by default, it doesn't get added in. So my long section, when it plots, will just use this sampling, but I'm getting all this extra sampling for that nice detail as I'm going around the curves. Now, we're going to look at this option in a second, layers, but for the time being, I'm going to click OK. I'm not really too interested in the vertical design at the moment because that's going to be set up later. The one thing that we would be looking at, first of all, is setting up the template. So I want my regular 150 high template all the way through, transition from this point to this point, maintain it from this point to this point, and then transition back. Now, normally, when you want that to happen, you'd have to go in and use add extra sections to make sure you have those changes available to make that change. The same could be said, and I'm not going to be doing it today, but for the pram crossing, you may be looking at just applying a different template. Now, for the eagle-eyed viewers, you may see there are little red lines being drawn in the background, and I've also done that here. You can use a line position to control how samples are added to your string. So if I decide that I want to have a sample here and here, in addition to all the others that are being added in, just take a look at the layer first of all. It's called section positions. I go roads, resample, return A, use layers. And it has to be a line, can't be a polyline. So for every endpoint of that line that I've drawn, a section will be created. So I go section positions. Now, again, when it comes to search offset, you'll notice I've actually got that being drawn up here for road one later. If you have one layer across your whole project that's using that you're going to be using for section positions, you can either do one of two things: create an individual layer that's unique to each string. So I could call this section positions KR1, and KR2 would have a different layer, or just change the search offset. I've been caught out by this many times, where the section positions from a line that's been drawn 10 meters away, because I put in 10, is actually being applied to this particular design. So I'm going to put in here just one, okay? Because that polyline is, that line, important, is a line, is just here.
Hey, Jonathan, you can also use arcs as well.
Thank you, Todd. You can also use arcs as well.
It's just not polylines. That's the caveat.
Yeah, nothing will happen if you put a polyline in.
And the search distance is left and right of the alignment too. So it is in both directions. So drafting either side.
Thank you, Todd. Very handy. Adding sample sections by layer, yes, include with the others. I don't want to lose the others. Apply and exit, click OK. Now, if we go and turn on the sample positions, sample lines for Kerb Return A here, you'll notice that I've now got that, and at the start here and at the end, I've also got them being picked up for this particular location. If you're doing laybacks, here's an example of where you could do it. So if I was to draw this along these lines, it's rough, but if that's a line, those are lines, you get one there, one there, one there, one there, and immediately that saves you having to go and pick them manually. But also, if you're drafting your design changes, if you've actually used a layer that you've drafted on, and you need to make those tweaks, then all you do is go and resample, and you'll have those section positions adjusted. Really good little tip, that one. So I've got my samples. I just need to make sure that my template is now transitioning. So I'm going to go to the design data form and essentially apply the multiple templates that I want through here nice and quickly. So I'm going to use the picker tool because the changes or the sections are already there through the section samples. I can just go ahead and do this. So I'm just going to go ahead and pick using my snaps. It's going to pick the end of that line. That's also a handy point to allow me to pick. And you can see that I've got that template going in. I'm going to add very quickly just the remainder. And the idea is here that if you've never done multiple templates before, I'd be going right side. So this is the template that you're transitioning to. So this is not the template that I'm currently using. It's the one I'm transitioning to. And then I use merge. If you've ever wondered what merge is saying, hey, I'd like you to transition from the template that's before to the one that I'm just about to pick. Add update. Then I go and add another entry, pick, start point, end point. Now this is just basically saying, hey, maintain this template all the way through. So I'm going to pick right side with 75 mil, add update. This is not a transition, so I can just leave it blank. Then we're going to be picking the next set of coordinates or next point, sorry. What's the template called? Well, this one, I'm going back down or transitioning back to my original template with 150 curve face, and it's a transition. So it's a yes. It's like a merge sandwich. You'll notice you've always got the I've just noticed that number hasn't quite picked up as it should do, so let's just make sure that's the same. Always just make sure you double check your numbers for your changes. It's like a merge sandwich. So a merge is always generally it's always in between two others. It doesn't always have to be though. Lastly, we'll just say from, and I'm going to just type this one in because I can see the number, 19.598 to the very end. We're going to maintain our full curb face at update. Now, you could take that process for that pram crossing. Okay, you can also use design variations. There's a multiple way in which you can actually achieve this, but design variation to maybe push the code back of the curb code out if you want to. Next, I want to make sure that my saw cut code, and let's open up a cross section here, just to have a look, is positioned onto the existing surface, because this is critical to set up my my design elevation of my center line. Variations, add, and we're just going to do the design data form way, set code to surface, pick my saw cut code all the way through, and match onto the NS. I have got an alignment there, don't really need to use it because it's a 600 mil constant offset. That's now positioned it. Okay, now, insofar as sort of setting this up, that's all really I need to do at this particular point. Okay, so I'm going to open up the vertical design. This, in fact, we'll close down the, no, we'll leave the cross section open. At this point, I think this is where most people tend to get a little bit stuck as to how I can set the elevation of my design, i.e. this here, based on a slope from a nominal position in the drawing to a position where I have a code and then have that projected through. And this is the way that you do it. Now, I'm a big advocate of this particular tool, only because the more people I mention to it about who are involved with a lot of reconstruction, the more they go, I wish I'd known about that tool sooner. Auto profile. Now, before we get properly stuck in, we'll do it now. If you haven't seen this tool before, I've unpacked it in, as I said, a couple of webinars. Row widening, if you get a chance to go to our YouTube channel, and also put string tech, I think it's independent string design or string design. Either way, have a look. I'll also put it in the comment section of the YouTube video. Reference point. So what's going to happen? This is where I don't have any design to work with. Okay, I'm working with existing points on an existing surface. And I might just have to move some things around here because it's going to get a little bit cluttered. I just want to give you some context on screen as to what's happening here. There we go, reference point. Okay, so I want to take the slope from my offset crown here to my saw cut and then have that projected through to set my elevation. To do that, if I have no design and no code, I have no code here. There's no code here either. The only way that that can happen, and I've just remembered I've missed one tiny little thing before I do this. It'll make more sense in a second. I'm going to go and add in an extra section, one extra section of my choice, and that is this location here. Can you see here, we've got an offset alignment, which is our offset crown, which is going to be giving us a start point of our slope on this side. Well, I can't use that alignment when I'm round the corner. I need to be using this one instead. So this point, or this chainage, which I'm just about to put in, is the break point for where I'm going to be saying, hey, use this alignment, but when I've got round the corner, use this one instead. The same would go if I just had two center lines here. I could use this point here. If I didn't have these offset crowns, I'd still be adding that point. I'm going to click and add. There you go, 25.554. Let's now just quickly skip back into auto profile reference point. And the reason why that change is important is because I'm going to plug it in here in a second. So I'm going to use from sampled surface. If I've got alignments over my sampled surface, which is the NS, I can use the surface elevations to help me with my projection here. The reference string, it may seem a bit odd that you're putting a reference string in, but you always pick the string that you're working with. Okay, so Kerb Return A is what I'm working with. From alignment is which alignment are you going to be starting with? Well, I'm going to be using my Kerb Return A left saw cut. Now, this is just a Civil 3D offset alignment, and you can just see it's in magenta down there. Then I'd like to take the slope between it and my saw cut and have that slope projected through. I'm going to use 2 points. So the way it works is that you'll notice I'm not picking codes here. This is why I have an alignment created for the offset, because I can't pick a code. I'm going to say from the road 1 crown, hang on a second, picking road 1 crown right, which is this one here, to my Kerb Return A left saw cut. I could have named these a bit better, but technically that is correct. So from this particular alignment to this particular alignment, using the sampled surface, I'd like you to project that slope through and set the design of my Kerb Return. Bear in mind that the saw cut is positioned at the natural surface, so that works. Let's now click OK. It's not going to work perfectly because of 2 things. One, I want this to happen up to this point here. Let's go OK. Calculate profile. Now, calculate profile normally now stays open in the current version, so I can go back and make tweaks. That to me doesn't look maybe as correct as it should do. So I'm going to go back in, double click on the entry and reverse slope. If you don't get these alignments the right way around, the calculation is reversed. So say you're going to pick them, just go and hit reverse, calculate profile. That's looking a bit more like it. Okay. Going to click on close, and you can see at that particular cross section, I mean, we're pretty much on the natural surface anyway, because that road slope is pretty consistent. But if it wasn't and we're further back, then we've got that position as we want it. What we now need to do is to tell it to do the remainder of the road. Okay, so I'm going to go auto profile, reference point, sampled surface, the string I'm working with, from alignment. This time I'm going to be picking the road 2 offset crown, which is the one that's nicely hidden behind the forms that I've got shown on screen at the moment. Obviously, you'll know which alignment you're working with, but this is the alignment I'm going to be working with here. 2 points from alignment. I'm going to go using the road 2 crown left to Kerb Return A saw cut, same position. Click OK, calculate profile. There might be the odd one or two it can't calculate, and that's probably why it's just done that. So we'll just come back in here. I didn't put the right chainage. So there's an example, guys, if you don't pay attention to the chainage values you're putting in. So I just told it to obliterate everything I've done on the first entry, but that's fine because I can go in and change it. I know that my previous entry ends at 25.554. I want this one just to start a little bit further round. We'll go 25.55, in fact, 56. There we go. Let's go OK, calculate profile. Still a little bit of a niggle there. And the reason is, again, all it does is it comes down to reversing the slope. The slope is being calculated backwards. Calculate profile. There we go. Now, this isn't perfect, and I'm not suggesting that it is, but what it is giving you is pretty much a very, very close attempt. And this is what auto profile is about. It's not saying, hey, here's a finished design. It's giving you a very close approximation of your design. The last thing I would look to do is to, probably for the first meter and the last meter, is just match up to, and I'm not going to do it just for time, but match up to the existing surface. Okay. Typically, in the discussions I've had with people within the industry, yeah, okay, I'd maybe tie in for the first meter and tie up for the last meter. Okay, so that's how we'd set that up. I'm going to click calculate profile again, click on close, and now I have, and in fact, if I open up a cross section further round, that's set up. Now, obviously, I can't see what that slope is. The cross-section viewer doesn't display that for me, but I know that I'm near as matching onto that particular slope, which is what I'm after. Todd, any questions so far on this?
There's been a couple of questions, but I've been able to answer them, but I can summarize for people. So the first one was about doing the template changes as variations, which you answered for me anyway, but I did answer that one. It is certainly an alternative. Instead of doing different templates, you could just do variations in your controls for the cross sections to raise and lower the face of the curb to do the transition across the crossing. Absolutely. There for you.
Yep.
And then the other one was just about picking. I might say this one out loud just because benefit of everybody. When you're picking the changes, particularly when you were doing the template entries,
yep.
When you got the wrong one, the reason that tends to happen is if there's a concentration of samples, and I noticed that there was a couple in your locations where you had some of those extra points. The software will pick the one closest to the physical pick you do in the drawing, and it may not be the one you want. So there's a couple of ways you can fix it. One, you zoom in and pick again, and you go to the right one you want. Alternatively, you probably should turn on all the sample lines just so you can see which ones are actually where, so that you know which one you're after. The biggest trick would be to actually use the snaps in Civil 3D or AutoCAD and snap to the end of that line you drew to control the sampling in the first place, and then you're going to get the exact same point you want.
Yeah, no, I unfortunately I did. So,
yeah, okay.
But there are multiple in there. So it was just it could just be possibly a calculation where the software's gone, that one looks like I could have been the one. There is like you say, there is a concentration. So, in fact, that's why I ended up just saying, look, just check your numbers.
Can you leave that up, because questions just come in about what merge means. So I know you did explain it, so I'm just going to summarize it for everybody. So there was a question about what's merge versus non-merge in the function. So if you had set those entries to not merging, then it's an instantaneous change in your template, whereas the merge allows it to transition between the template before and the template after the one with the merge entry turned on.
Yep.
So essentially it allows you to do kind of like the variation for the linear regression, essentially between a code. It allows you to do it via an entire template at once.
Yep.
So yeah, that was a good opportunity that you had it up on the screen just as that question came in.
Fantastic. Thank you very much. Excellent.
No worries. That's all.
Cool. Okie dokie. Well, look, just one thing while we're in here, actually, guys, is the vertical design at the moment. If I was to put a long section of this, yes, I wouldn't have heaps of sample positions, but I would have a lot of IPs, which means that this would look not the best when it comes to the actual design. What I'm going to suggest you do is use or engage auto profile again to apply what's known as fitting. Now, fit parameters under here says, hey, what I'm going to try and do, and we've actually got a help text down the bottom which says apply fitting or smoothing to the resulting vertical design. So in here, I'm going to say from 0 to 1,000, apply a cut factor, and this is not a percentage, this is a height. So if I was to type in, say, 30 mil, which in this thing, this particular design is probably a bit too much. Apply vertical curves of 10. Now, it's really unlikely it can achieve any of that, okay? But the idea is that it's going to go in and try, you could add a level adjustment, try as best it can, apply some fitting over the top with that criteria, whilst also trying to achieve reference point. We're trying to hand it's trying to juggle a lot of balls at the same time. So there's an example of where you can take an auto profile result and then have the software try and help manage the number of IPs for you. Not suggesting it's perfect. Again, this is down to you as designers to go in and manage. You may find that you remove that fit parameters entry once you've added it because you don't want it to keep adding in afterwards. But there's an example of where you can use that to try and help you with your design once it's been calculated. So our Kerb Return in inverted commas is finished or designed to some extent. The process of that was really the key part for this. Now let's have a look at how we can begin to build things up here. I want to put a footpath in here, and I think for a lot of you, you may go ahead and look at either designing this as two separate strings, or you may look at designing it with profile strings as an example. Whereas really for a lot of incidental line work such as this, and design work, having spoken to a particular designer this week, noticed that on their projects, they just use grading strings. This type of thing doesn't need an alignment. It's part of my model, but I don't need a Civil 3D alignment here. I don't really need to do anything other than just simply create it for the model. So I'm going to just use a grading string. I'm going to come up here, pick my inside polyline, and there's another good reason why I use a grading string. It's going to call this footpath. The template I'm going to be using is really, really simple. It's just called footpath. Okay, minus 3%, 1.25 meters to the left here. Okay, I'm going to pick that template. The target surface is just the NS. The initial elevation, 6 meters above sea level. Okay, well, that's okay. How often do I want this to sample the surface? Every 1 meter. I don't want a surface. I can have a surface if I want. I'm not that bothered because in a minute it's going to be a composite of that and the Kerb Return in a second with a built model. I'm simply going to click Create Update. Now, at this point, visually, not a lot will have happened. Okay, I can go to the vertical grading, and you can see if I right-click, there's my wonderful little footpath. However, What I want it to do is to be matching on at this point, which is super critical to my design, onto the existing surface. So really, I don't need an auto profile entry to manage that onto the existing surface. Once it's done, it's done. And I use this tool to do that. Every sample position will now match on to the existing surface. Okay. Auto profile has its place, particularly if the surface you're matching onto is likely to possibly change or need some control in respect of other auto profile entries. But if you just want to quickly stick a string onto the sampled surface, that's the button to do it. Okay, so my footpath is in. Now, I was, at this point, going to create these. Okay, now, there is very little point at this precise moment creating what is essentially just a single string with no template that connects here and connects here, because when I model in a second, I'm going to model between the back of Kerb here and this footpath. If the slope between this footpath and this back of Kerb was of high importance to me and I needed to check it, I probably would create a string here, okay? A grading string. I would match up the grading string at this end to a surface, which I'll explain in a second, and I would match up using reference surface, match up the grading string at this point to my grading string surface, okay? So if I had a grading string surface, I could do this. Now, really, I know the slopes here aren't really a problem. So I'm not going to bother modeling what is essentially a line on the drawing. Okay. If I'm going to draft, I've got everything I need to in here. There are multiple ways you can do this. You could design this as a single string all the way around, matching onto a surface here, onto a surface here. Just out of interest, guys, if you create a profile string, you'll notice that there is no surface to work with. However, every string you create, if I open up the vertical design, because this is the only way you can do it, you can get every string you create to create its own, basically its own surface. Even with Total Model, if you create a Kerb Return, you can use this particular tool. You go to Model, String Surface. Now, if you've ever seen in your drawing, and we'll turn on the mesh here. If you've ever seen in your drawing a surface that begins with ARD, it's an old surface name. That is a live representation of your string. And it's a surface. So I could match onto that surface just here. I could match onto that grading string surface if I created it over here and just use auto profile to do it. So that little surface can just stay there in the background. I can delete it in Surface Manager if I want, but it's always there. And you can do that for any string. In fact, that's what I was going to do that in the webinar, but unfortunately, I'm not going to have the time to do that. So I now have my footpath generated. Over here, I've got my Kerb Return here. I basically want to join these two things together. And the way that we join strings together is to use Model Builder. Now, because I'm not using Total Model, I'm not using road strings or network strings, I don't need to link it to Auto Model. I'm just going to create a bare bones model here that combines two things. Here's Kerb A. Click OK. I'm simply going to take two strings, this one, and build and join them together. Done. Now, I'm going to make a point of showing you this because I nearly did a video for YouTube. And for some of you, you may be wondering why your line work for Model Builder is always drawn at a completely different color to the line work that you've maybe picked in assigned layers. The reason why is because it's actually controlled through this form. Let me just quickly show you. So if I click this button here, what you'll see here is, if I click on default, it's probably easier to explain. When you create a Model Builder model, this is the colors it uses for that line work. So if you've ever wondered where on earth they are set, it's in here. And normally what happens, every code that you create within your models gradually gets appended in here. So once you've created or gone through and set your coloring, you can actually save this as a separate file, which is why when I go to this button, it'll ask me two questions. It says, hey, if I create a Model Builder model, what line work file would you like me to use? And I've basically gone and created this one. Okay, I'm going to change it to default. You'll see the difference. When I show hidden line work, which is this button here, this button allows you to see any line work that you've trimmed with Model Builder. It uses one called hide display, which essentially means they're all going in gray. And you notice that's just changed to yellow. Okay, that's because my Model Builder, and probably for most of you, unless you've gone in and changed this, your Model Builder file, a coloring file that you're using, wrong button. Let's go back down here. This is the one. This is the one I want to set, Model Builder. and then hide display. That's the one the default one is the one that you normally get set. So if you ever want to change that, that's the place to do it. Now, in the latest version of Civil Site Design, I'm going to save this first, you can now show the CAD line work in addition to fast draw. So if I wanted to, I could just go, hey, show me CAD entities instead. Now, due to the way in which I've set my assign layers up for 2D polylines, you won't notice the difference. But what you will find is that there are now polylines, he says, as he goes back in and just double checks what he actually picked it. That's Kerb B. Typically pick the wrong one. Knew that was going to throw me out. There you go. So this is actually the line work, and this will update live. If you've got some really big, meaty drawings, projects, I wouldn't suggest you maintain CAD polylines all the way through, but you can now do that in Toggle Display. Now, I've got a model, and if we just quickly have a look at that model, which is, let's go back in here, built model, Kerb A. Okay, first thing I would always do, guys, is just go in and just clean your line work up. This is Kerb B. I knew that was going to trip me up all the way through the webinar. Just renaming it. I started off with Kerb 1 and 2 and then decided I'd go Kerb A and B. And from that point, I've just consistently then got the naming the wrong way round. So I'm just using edits here. And again, if you haven't seen this tool before, this is a way of trimming up your built model. And if you didn't know this, you can actually grab that line that's been drawn in the background and just tweak it. Nothing worse than keep going in and redrawing another line, just grip edit the thing. Another tip, don't click on build surface, okay? Build surface on older versions used to do a very different type of build to what you do in a built model, okay? You don't need to anyway, there's nothing for it to build, as it were. There's my design, okay? Now I want to take this curb and this curb and have them combined to the natural. The reason for this is because in a minute, I'm going to create a crossing, and this is going to become a grading string, this polyline here. What I want to have, well, what I wanted to do is to match onto my curb at this end, my curb at this end, but then be 75 mil above the natural all the way through. Now, I don't have to create a pasted surface, but a pasted surface is going to basically incorporate those three things and remain live. So if one of the design elements, such as the curb, change, that pasted surface will adapt and also change. Think of it as an intelligent combined surface. So let's have a look at how this might happen. I go up to the model builder pull down and paste surfaces. Conveniently, there is one already in there. So I'm just going to just delete that group, say yes, goodbye. Add group means what's the name of my layer? Okay, sorry, my combined surface. So I'm going to call this combined curbs and NS. Really simple. Click on add. Now you don't have to hold control. When you pick, you literally just left click, and we've assumed that if you're going to want more than one, there's a high chance you'd probably hit control. So we've done this for you. The thing that you make sure, first of all, is that if you imagine, right, these are the order in which they are drawn. So if I was to create this combined surface at the moment, my curbs would be drawn and then the NS would be drawn afterwards, which basically means it would obliterate everything on top of it or underneath it. So the first thing that happens is that the NS is drawn first, and then this is drawn, and then that's drawn. Build update surface. Now visually, there's probably not a lot you can see on screen. So I'm going to say save and close. I'm just going to turn off the mesh. These are grips, if you haven't seen them before. They exist in control and active settings. Here we go. Here's my pasted surface. Now I have a combined surface that I can design that crossing onto. Okay, now I don't know if I've even been to Model Viewer yet. Apologies if I haven't, but again, just because of time. Well, there you go. There's the first curb. Let's have a look at the other one. Going to go to Toggle Display. This is where you can actually see if you've got a single string, okay, that's a profile string, it doesn't normally come out with the surface. So you're thinking, well, how can I show that in Model Viewer? That's where you can use that little string surface, the one that begins with ARD, and actually check it on. So if I click here, there's my string, okay, and that will change, okay. You can see the transition. There's the merge, yes. There's the merge, yes. Now, what I don't want to see is this just single string. I want to see this built model, which combines that footpath. There we go. If you think about it, as I said earlier, that footpath, the elevations would be matching in here, matching in here. What benefit do I have for modeling it? not much. Okay, it's going to be following exactly the same elevations as these triangles anyway. So it really is up to you as to whether or not you would do that. Right, let's have a look at, in fact, I'm just going to minimize this. Let's have a look at combining, sorry, not combining, creating this crossing. So the trick with this, if we just turn off the mesh, is I'm going to use grading strings. There's no point. I mean, I say there's no point. I could create profile strings if I wanted through here, but for speed, just ease of using a polyline, I'm going to create, just use grading strings. One thing I'm going to do, first of all, is just run a quick cleanup. I should say this, and it is mentioned in toggle display. Let's just go back in here. When you turn off CAD entities, we don't delete the CAD entities. It requires you to run a cleanup. So I'm going to go OK. The CAD entities are still there. Just run a cleanup as if you would do normally. So I've got my polyline, which is just here. And you can see this is the top of Kerb code. It's really important to me that I have a slight overlap of this string onto the top of Kerb, because essentially that's what it's going to be matching up to. And here, there is a tiny overlap. I might just stretch this using this parallel just a little bit. Okay, just a tiny bit. This one, not so much of an issue because this is going to be the toe, but it's important I have a tiny overlap with the top of the curb. Otherwise, I'm just going to just use this here. And look, this isn't exactly perfect, but from a modeling perspective, you can see I've got small overlap here as well. That's okay. Now, how do we go about creating it? Well, we go about creating 4 strings, 2 for the toe, 2 for the top. So let's go about creating these now. I'm going to go create grading. I'm going to put the first one on the toe here. So this is crossing, toe, and we'll call this south. Okay. No template. Okay. What target surface am I picking? Well, I'm picking the combined. This is another, or the pasted surface, another good reason, because I want it to make sure it marries up to my gutter here, but then match onto the existing and then back onto the gutter again. So this is why this surface is so handy. The spacings, I'm going to go every 100 mil. I really want some really heavily nice dense sampling going on. Create update, vertical grading, and really I could use an auto profile. It might be of benefit to me to do that because I can set up what's known as a thread later on. So if my pasted surface updates, which it might, I can create a thread to have this updated. Now, for the time being, I'm just going to go through here, calculate profile. That's the only one I'm going to do like that. The others, I'm just going to simply use the grid editor. So there's the first string. Close this down. I'm going to create another one. Crossing. Apologies for the speedy typing here. Tie. And we're going north. That was an utter disaster typing-wise. But the grading string form remembers your previous settings. So I don't want a surface. There's my surface I'm going to be using. I don't want it to create a surface for a single line. No template, every 100 mil, create update. Okay, going to just use the vertical grading and match onto the existing surface, just using this sort of apocalyptic method of matching on, as you can see there. Now, the top two, I've got a slightly different approach. I'm going to go create grading, click on the top one, and we're going to call this crossing. Got this top and north. Sorry, south. There we go. Most of it remains the same. Okay, going to use 100 mil for the sampling. Going to use the pasted surface. Click create update. However, when I open up the vertical design, you should see, because I've nibbled over the top of that top of Kerb, it's being picked up here and here. That's what I want to tie into for the first IP and the last IP. But as it's being transferred over the top of the road, I need it to maintain 75 mil. So this is the way, and again, there could be multiple ways of attacking this. This is the approach that I would personally be taking. I'm going to go auto profile, and I'm going to go reference surface, and I'm going to be picking a very, very small number. So for the first 10 mil, match onto the pasted surface. Okay, that, calculate profile. There we go. There's that point. If I add something that's above 100 mil, it's obviously going to be transferring that to the next sample. So I'm making that very small. For the next section, I'm going to be going reference surface, and I just make sure that I'm ahead of that particular point. So I'm going to make this 100 mil. To the end, now one thing I didn't do was move this around so you could all see what the end chainage might be. which is around 8.4. I actually know what the number is. You should probably go to, oh, there we go, it's 8.44. There's the polyline length. So just before the end, I want it to be 75 mil over the top. So I go reference surface from 100 mil to 8 point, let's make this 8.43. Reference the pasted surface, but use fitting. I don't want to have, this is basically a bit like fit parameters if you want it. I don't want any of this happening. I just want to be 75 mil above. Click OK. Calculate profile. There we go. Now, the last entry is to cover that last little piece. So I go reference surface. Bear in mind, by the way, you could use your little string surfaces. The fact is I'm using a pasted surface, but they come in handy everywhere. We're going to say from 8.43 and 1, just to avoid overlapping the point I've already created. And we'll just say match onto the existing surface and calculate profile. Hopefully you all saw that happen. So that's the process we use to then have the elevations being managed. All of this is dynamic. So if that Kerb Return changes, I can come back in, the pasted surface will update, and you don't actually need to go auto profile anymore. You can hit this button and it refreshes all your auto profile entries. Last one, create grading. In fact, let's just close this down. Create grading and crossing top, and this one's the north side. Pretty much everything's the same. Create update, vertical grading, and I'm going to run through this very quickly. Same process. In fact, the values are nigh on the same numbers. So 0, 1, reference the pasted surface. Okay, that reference surface from 0.1 to 8.43. 8.43. Pasted surface, add 75 mil. Should have put the Q&A right in front of my my notes. Reference surface, and then from 8.431 to the end, match on. Okay, that, and calculate profile. And click on close. So there are my 4 strings. Now, if you want to be more accurate here and you've got some severe vertical design changes going through your existing road, then go ahead and put more on through the table. There's nothing to stop you doing that whatsoever. Just while I'm going to the next bit, Todd, any questions?
There was a couple of questions, but I think probably the only one I wanted to bring up was, actually there's 2 I want to bring up. Someone was asking about paste surface and troubles with boundaries and NS, and I'm hoping my explanation was correct, but I might say it out loud. The NS has to be the all-encompassing boundary. So in other words, the subsequent surfaces you're pasting into your NS can't extend beyond the NS boundary, otherwise the paste doesn't work. So hopefully that makes sense to Ben, who was asking that question. So in other words, your NS is going to be all-encompassing. That's the best way to think of it.
Yep.
And there was someone about the YouTube channel, which we'll show at the end, but I'm going to send a link out of what it is in a sec. And there's another one just popped in, asked a question about the import-export on the auto profile.
Mm-hmm. Good question.
There is one in there. Do you
mind
is it
where? Sorry, is it a question about where is it?
Yes, I think that might.
Yes,
yeah, it would be good to have one. So I just wanted you to bring it up. So it's changed position. So it's now up under the file menu at the top there, where JT's just highlighting. Yep. So it actually always had one. It just the function's been moved in the latest reinvent. Yeah. So yeah, you go File, Import, Export, and you can export all of the entries. So you can do that as your kind of your design history if you wanted to have version 1, version 2 to maybe look at 2 alternatives.
Yeah. Now, auto profile, the import export does have a sort of a bit of a kicker when you do use it. What it doesn't do is collate these 3 entries I've got here, export them as 3 entries and bring them back as 3 entries. It exports them in one single file and brings them back as one single entry, which you wouldn't be able to edit. You wouldn't be able to say,
I didn't know that.
No, so that particular reference point entry there, I want to make a tweak to it. Well, I've exported it, deleted all of this and imported. It just grabs the whole lot, bundles them together and brings them back in as a single entry again. So it has its place for options, certainly, but just be wary of that. Don't go ahead and delete everything or think, oh, I'm just going to export that and then import, because it'll then, you just have to be, just a word of caution. But yeah, not many people quite a few people I've spoken to have had this issue where they've gone, well, where have you put import export now? And it's snuck under file. So yeah, thanks, Todd.
No worries.
Okie dokie. So look, the crossing just needs to be modeled. So I need, rather than joining this to anything else, it's going to act like a bit of a sort of, I don't know, like a cup going over the model, like a shell. We're just going to lay it on top of the design. So I'm going to go model builder, create model, crossing. I tell you what, if I could spell crossing today, that would be fantastic. Click OK, include, and I'm going to grab these and then click build. So what I'm going to do is just turn on the mesh for the crossing, click OK. Now, this will not be perfect insofar as modeling, because if I click on save, yes, I want to save that, close that down. What I am doing is overlapping behind the curb here. So the back of the curb's here, and currently the triangulation is carving its way through it. However, if I go into model viewer, which is obviously still open, let's just see if I can fire that up. Toggle display, I now have another mini model I can work with. Click OK. Because it overlaps, it actually cuts underneath. It actually looks very good. When you come to do the actual model, you can see it works really well. You can see I've got my transition of my curb here on both sides, and it works. I'd say, look, for most of what you're looking to do, it works very well. The only slight niggle I would say with this is when it comes to actually generating cross sections along road 1, which is what I'm going to do in a minute. One other thing I would mention though is you can do this in model view, and it's just a bit of fun. The line marking, which I've got on 2 turn off layers here. I've got some, in fact, let's just turn off the mesh as well. This is where grips come in so handy. I've got a couple of layers, and these are just polylines that I've drawn with width. Nothing particularly fancy here. What I'm going to do is ask the software to use those polylines and demonstrate them, or display them, demonstrate them even, onto the crossing. To do that, you go line marking, marking setup, and you can say, just use a layer with polylines. So I kind of pre-populated this for speed, but I've got a layer called LM1 at the top here. I'd like that to be the 600 mil wide line marking, please. So I picked that from my library. I'd like it to reference the crossing surface that I've got. I've also got a layer called LM2, as we can see here. I'm going to use the 150, which has got small increment, which means it's going to read that surface in detail and use the same thing. Click OK. You won't see the marking initially because I've got marking turned off. And there's marking turned on. There we go. So most of what you were seeing in any of that PowerPoint, etc., was really just screenshots of this, which overall gives you a pretty good sense of what's happening. Now, one thing I think I mentioned on the webinar chat, as it were, the webinar, sorry, newsletter, was the ability to then manage the clashing. So I've got this, designed, as it were, with the elevations. I've assumed that the positions of the toe are where they should be, but now I want to do some kind of check. So what I've done is I've put a string, or created a profile string on top of road 1 with no template. What you may notice is that I have drawn lines where I want to have sample positions. So I want to have a sample here, there, and there. Meaning that when I come to do what I'm just about to do, all of the hard work's done for me. So let's just have a quick look at toggle display and have a look at road. Okay, no, I thought I had it created. I take that back. I'm going to go profile string. Well, there you go. You get to see it firsthand. What surface do I want to use? How often do I want to sample? Well, look, I'm not interested in really lots of sampling all the way along this road. So I'm going to go 5, 5, and 5. I would like it to use some layers, though. I'd like it to use the section positions, search offset of 1, as you saw in the first part of this webinar, and probably between this point here and this point here, so we'll say between 10 and 20, I want some really quite tight sampling. So I'm going to go user sampling between 10 and 20, sampling of, say, 0.5. Okay, that, and okay. Not particularly exciting, but what I can do is, because I have sample lines where the design of the crossing is positioned, I can now do this. I'm going to go auto profile, and we're going to go reference. How am I going to do this? I'm going to drape onto the, which surface is going to drape onto? Just thinking out loud here. We'll drape onto the NS. Yeah, do you know what? I'm actually going to pick the chain edges here. So I know that it's around, I've got to remember where the chain edges are. This is why I had it kind of pre-created. So here we go. So we're looking at NS, match onto the NS up to 11.7, and all the way up to, there we go, 18.958. So it's really helpful having those sample positions. Save me some blushes. So we're going to go reference surface from up to 11.757. Match onto the natural, could be the pasted, let's face it. Notice how I'm not picking the pasted. The pasted doesn't include the crossing, okay? I don't want to paste the crossing into that surface because it'll end up self-referencing itself, okay? Reference surface from 11 point, and we'll go 757 again, it should work, all the way to 18.958, match onto the, and this is where we go crossing. Okay, let's just have a look how it looks. There we go. Not too concerned maybe with the NS part, but we'll just do that just to sort of finish it off. And we'll go point, what do we go, 96 to the end, match back onto the NS and calculate profile. Okay, that is giving me a very detailed representation at the positions where it crosses of my design. Now, this is just a quick aside, but if you wanted to do a clash check on this, you can do this by going to the Analyze tab, driveway check, and then pick one of these two vehicles. In this case, I'll go with the B85, mouse forward and reverse, click OK. Now, bear in mind, the scale is at 1 to 100 vertically. If there was any clashes, and I'll just set this back here, go home and set this to 4. There you go, it's a little bit better. If there was any clashes, you'll actually see these little white markers appear. And in fact, I think if I just move this up, there you go. You'll actually get a clash on the underside of the vehicle or the actual vehicle itself, or sorry, the frontage of the vehicle, to indicate that there are problems. So this is quite a neat tool of just doing a very quick check. You can see here with the B99, just checking that the vehicle is not going to clash. If you want to create other vehicles, it is found underneath set layer, clearance templates. Okay, so this is where they're stored. So have a look at the ones that have already been created, and you guys can go ahead and create your own if you need to. Lastly, unless there's any other questions imminent, Todd, we'll just have a quick look at plotting.
No questions. I just wanted to make a comment about what you just did then.
Go for it. Yes.
No. From my experience doing these things in various locations, that's probably the critical part, is actually making sure that the vehicle can get over the hump, because you can design the ramps perfectly fine from relative to the top, but you got to consider the bottom as well. So I found doing that sort of check was actually kind of like the cake on the end of the project, is that you verify that everything actually fits into the real world. And I actually used to run at least 3. I'd run through the cuts like you did there, and then I'd actually run one on the left and right directions, just to actually look at the direction of travel for each vehicle. And then if it was really, really painful, I'd actually run one at each wheel path in each direction. So there'd be 2 on each side, depending on how complicated it was. But I can't stress enough how golden that little driveway tool is actually useful for checking this sort of stuff from a actual integration into your real world stuff.
Thank you very much, Todd. Cheers.
And to answer your first question, no, there are no more questions.
Okay, thanks. Excellent. All right, no worries. Well, look, we'll just look at a few things. First of all, long section plotting for our Kerb Return here. I think I'm just going to use an out-of-the-box style. So the good thing with this, let's go load style, shall we? Even 1 to 250, I'll be honest with you, is too short. I'd go 1 to 100 personally. If I had gone through and sampled those arcs at every half meter on the main sampling, that would have caused me all sorts of headaches with respect to picking or unchecking the sampled sections. But because I added them as extras, I'm getting that nice geometry on the design, but I'm not getting them applied to my long section. I'm only getting the IPs and the vertical and the horizontal here at the critical points, which is handy. So very straightforward cross section and plot to layout. Don't know why I did that, didn't need to, but anyway, cross sections. We're going to go with a cross section of the Kerb Return as well. One thing I forgot to mention, sorry, was if you're designing along the invert, you remember here in the reference point entry, I said, hey, take the slope between those 2 points. if you're designing and you've got a little section of gutter that is kind of just in the way of all of this, then you could say take off 40 mil, because essentially my gutter is a 40 mil high gutter. Therefore, if I remove it from the calculation, that should make the adjustment and position my centerline, or position my control, which would be the invert, in the right place. So just bear that in mind. That's a neat way of being able to make that change whilst maintain that calculation. Very quickly, cross sections. Again, this is all, I'll be honest with you, not very exciting. We've just printed off basically a single curb. What I'd like to show is the built model. And the way I would do that is to go and remove design. And nowadays, we get you to pick a surface. You don't have to pick CSD built models. You can go surfaces, pick your built model, which in my case would be Kerb A. Make sure it's on X block design, which is this lovely blue line which goes across. Click OK. And there we go. So I'm getting a little bit more context. Obviously, there is no design in here. Okay. Lastly, close that down. And look, this is quite an interesting one. I'm going to plot cross sections along road 1, but combine these 3 things together. So I'm going to go, I mean, if you want to see a long section, you can do, but I don't see what benefit we gain from that. But if we want to plot cross sections, we're going to go cross sections, road 1. Not worried about section samples because they're, in all honesty, irrelevant, because now we have the section list. And you pick whatever changes you want for cross sections. So in this case, I'll just pick 10 meter spacings. What I'm going to do is take the 3, or at least the 2 curbs, and have them drawn on the same band, and then add the crossing. So the way that this happens is it happens exactly the same way I did before. Remove design, because that's the design of our row 1 string. There is nothing there. Go preset bands, surfaces. Going to pick Kerb A, and then go across here. To be honest with you, you could also pick the pasted surface, but then the line work over the natural is all going to come up, and I don't want that. So there's the curb going in on that side. Now I want the other one. So you can actually right click, copy, Kerb B, click OK. Now the problem is I've got 2 different design elements on 2 separate lines, which I do not want. So what you can do is you can make Kerb B, make its band height very, very small. So in here, I'm just going to make this 50 mil, and then click apply. Now you can see the extra lines going on in here, okay? And I can, if I want to remove the band entirely, or remove the band line work, but what I'm going to do is override this and leave everything blank and apply. Now that, whoops, no, top line. Now there is a tiny extra sample here, which we've, or sample line and header, which we've got, but you can now see I've combined those 2 things together. The one thing I can't do is combine the crossing, because the crossing model overlaps inside the back of that curb. So it's not perfect, but if I go right click, copy, and go crossing, band controls, yep, that should just be its own band. Don't override, click OK. Now, one thing we don't have, annoyingly, is any sample or any cross section where the crossing is. So all we do is we tell it, using this particular spacing set is between 10 and 20. I'd like to see a sample every 1, or a cross section every 1 meter. Click OK. This is where you can see with the model, it might need a bit of tidying up. You can go through and delete the triangles if you want, but this is the type of thing you can do. So I've now got the crossing being modeled separately on top of that particular design.
Jonathan.
Todd.
So while you're there, we've got a question that's just come in that's kind of relevant to what you're looking at now. They just wanted to, a person wanted to know whether or not you can show the crossfall on these surfaces once you've added them.
Absolutely, yeah. So there's 2 ways you can do this. So first of all, crossfalls would need to be checked on for every section. Okay, click OK. The second part of this would be, if we want to go, how are we going to do this? It's Kerb A, Kerb B. So I think we'll have to do these individually. When you double click on an entry, there is something called section labels, and there is something called show crossfalls. This is the only part where I'm having to now just go through and cherry pick these little bits.
Sorry, I knew you were going to have to do that.
No, it's okay. It's okay. Let's just
but I thought it was relevant. It was a good question to ask.
It is a good question, yes. There is some defaults as to how we can control what is displayed. I'm just going to go apply here, just see what we get. Yeah, it's going to do a reasonable job on that, I think. 0.38. Let's just see if we can go back here and make this a little bit better. Where are we? Midpoint between two codes. It may, oh, there we go. Click OK. Now I'd undertake that same process for any surface in the job. So I'd be doing the same with curb B. I'd be doing the same with crossing if that was important to you. Okay, but that's how you can set that. That's a very good question. A lot of people do not know, or sometimes it's a question as to why I'm controlling them entirely separately. One, do I want to see them? Yes. Where do I want to see them? And then secondly, for that particular string, you can actually set up some unique defaults. Hopefully that answers the question.
Yes, it does. Thank you very much.
Marvelous. Well, look, minus that little one there, which there is literally nothing I can do about that other than just literally manually deleting that at the end. Really, that's everything I had to cover today. And what I might do is just try and summarize everything with this final slide. I appreciate I've gone well over time, folks, so I'm going to be very brief. But really, the focal point was to not look at designing strings with total model and using network strings, but independent string design, looking at how you control them. Using line work, as we saw there, a layer with lines, not polylines, to generate sample positions, auto profile to assist with the vertical design, not to do the design, but assist with that. Using grading strings. One thing I forgot to show you is how a grading string handles a corner, and I'm really sorry, I'm going to have to show you this, and this is why I chose a grading string. If you try and model this with a template as a profile string, you have to put a small radius on there because the software can't handle this corner. With a grading string, if I go surface creation here, okay, what we'll do is just turn on. We'll get that out in the edit. There we go. That's what a grading string will do at a corner. You can see that it manages that corner. That's the other reason why I've used that grading string. Okay. Sorry, back to the final slide. Model builder to combine the strings. Again, great use of how we can use model builder. Pasted surfaces to take those model builder models and join them onto the NS, and then combining different models. And these are really the kind of the key tips out of this particular webinar. Combining the different models into a single band for plotting. So there was a lot to take in there. I will be adding what's known as timestamps onto this YouTube video, so you can go in and pick the bits that are of interest to you when the recording is available, which will be available, I expect, hopefully today. If not, first thing tomorrow, it will be uploaded. And I'm probably going to put this together in a civil site design reconstruction playlist, because the other webinars I've done more recently have been mostly recon focused. And certainly we haven't really done anything that's involved things like network strings. It's all been independent string design. And it would be great, I think, to have those all in one single playlist, because they do get referenced. Today I've referenced them, so I'll put them up on the YouTube channel. You should see those up. Todd.
Sorry, I was muted then. You couldn't hear me.
Put you on the
So
spot.
no, we are all good. We have no outstanding questions. We've been able to answer them as we went through, or I've answered some of them in the background. Thank you very much, everybody, for attending, and thank you very much, Jonathan, for a very informative webinar. It's fantastic stuff. I must admit, I used to do this stuff as bread and butter from what I used to do when I was not working in civil survey solutions. So it's kind of like brought back memories, some of them good, some of them bad. Okay, once again, thank you very much, Jonathan.
Thank you. Cheers, Tom.
And thank you very much, everybody. Have a good afternoon, and we will see you next time.
Great stuff. Thank you. Thanks, guys. Thanks for attending. Cheers.
Thanks. Bye.